Algebra 2A, and welcome to lesson 59 using fractional exponents. Our goal today, we are going to extend the laws of exponents to include rational numbers, which are fractions. So how does a fractional exponent impact the numbers that we're working with? We'll start with our warm-up. Vocabulary. In the expression x to the a plus b, the term a plus b is called your exponent, and that's what we are going to look at today. We're going to look at when those exponents are fractions. Secondly, simplify x squared y to the fourth over x minus 1 y to the third. Whenever we're dividing two powers that have the same base, so these two powers have the same base, and these two powers have the same base, which are y's. If you're dividing those, you can use subtraction. So we are going to take first x to the second, which is our numerator exponent, minus the denominator's exponent, which is -1. And y's, we're going to take y to the 4 minus 3. And 2 minus the -1 is really like adding, so that's going to be x to the third. And 4 minus 3 is just going to be y. So there's our simplified version. Both those are positive exponents. If you wanted to, you could put a little 1 right there. And lastly, solve the square root of x is equal to 4. Now careful, we're not doing the square root of 4, we're doing the square root of something. So to undo a square root, like we've done with Pythagorean theorem, to undo squares, we take square roots. Now we're going the other way. To undo a square root, you can square both sides. So x is going to equal 16, and that's the only answer possible. So now we have reviewed our exponents. Now let's take a look at fractional exponents. These fractional exponents. So a fractional exponent is any exponent in the form m over n, where m and n are integers and n cannot equal 0 because we can't divide by 0. So the rational exponent property, rational exponents, so for m and n integers and n is not equal to 0, a to the 1 over n is equal to the nth root of a. So like for example, if we had a number a to the 1/3, that denominator 3 tells us which degree of root we're taking. So this would be the cube root of a, is what we would be looking at. And if you have a to the m over n, that is equivalent to the nth root of a to the m power, or you could have your power underneath your radical. So nth root of a to the m. So we are going to rewrite, anytime we start in a exponent form, we're going to rewrite them as radicals. So I'm really focused on the denominator because the denominator is going to tell me which type of root I am taking. So here I have a 4, so this means I'm going to be dealing with a 4th root. And my exponent, fractional exponent, has a 1 in the numerator, so that means the 10 and the x are both being raised to the first power, which I don't need to write that. But this would just be the 4th root of 10x. So there it is in radical form. Part 2, we've got two separate powers. So we've got p to the exponent of 1/3. We've got q to the exponent of 5 over 2. So p to the 1/3, that's going to be a index of 3. So I'm taking the 3rd root of p. And I've got q to the 5/2. So since I've got a 2 in my denominator, this is going to be a square root, which we don't need to rewrite the 2 in there. So this would just be the square root of q to the 5th. Now anytime this q to the 5th, anytime this this power of 5 is greater than that index, I can start to take out perfect squares. And with square roots, you can take out even powers. So I still got the cube root of p, but that q to the 5th I am thinking of as two separate values, q to the 4th times q, and any even power we can take the square root of, so something we've talked about back in lesson 41. So you got a cube root of p still, and the the square root of q to the 4th is going to be q squared, so that's a q squared times the square root of q. So there's that one q left in there that we cannot remove out. But there would be our radical form of that exponent. Are starting in radical form, so we are going to use the rules of fractional exponents, and we are going to convert this back to exponential form. So the key is I've got this 5th root, so my index right here is a 5. That means when I take 32, that's going to be a denominator in my exponent of 5. This a to the 10th, my denominator of that fraction is going to be 5, and then this b to the 15th, my denominator is going to be 5. So rewriting this in fractional exponent, it's going to be 32, and then that's going to be to the 1/5. So there's my 5, my index right here, becomes my denominator of my exponential. Then I've got a to the 10/5. And I've got a b to the 15/5. And then we're just looking to simplify. So 32 to the 1/5. Now, that is the 5th root of 32, which couple options that you can do. One option is you can use your power sheet. So the 32 is the result of taking 2 and multiplying it out 5 times. So the 5th root of 32 would be 2. Or you can use your calculator. So I do want to show you how to use your calculator. You can take a 32. You can hit your power button. Your fraction button is alpha y equals. Make a fraction up in your exponent, and you'd have a 1/5. So you can take these and make them, put them into your calculator. So again, that's what that would look like. And then you hit enter, and you will get 2. So again, to get that fraction button, alpha y equals, once you're up into your exponent, you can get that fraction button pretty easily by hitting alpha and y equals. All right, heading back to our problem. So 32 to the 1/5 is going to be 2. A to the 10/5, so a to the 2nd power, because I'm just taking 10 divided by 5 is 2, and then 15/5 is 3. And there we have it. At properties of fractional exponents, we're going to review just all the power rules, the exponent rules that we have seen in Algebra 1 and pre-algebra and so on. Negative exponent, anytime you have a negative exponent, that is like moving the power down to your denominator. If your negative exponent is in your denominator, then it would move your power to the numerator. Zero exponent property, anything to the 0 power is 1. The product of powers property is when you multiply 2 powers together that have the same base, you add their exponents. We kind of have talked about that. Quotient of powers property is when you divide 2 powers, you subtract their exponents. That's what we did in the warm-up today. Power to a power, if you have a power raised to another exponent, that's going to multiply your exponents. And a product to a power, when you have 2 numbers being multiplied together, a and b, raising to a power, they both get raised to that power. And lastly, if you have a quotient to a power, that means that both your numerator and denominator are being raised to that power. So this is a good reference to look back to as you start practicing when you get to your class check with the power rules. plus 125 to the 1/12th. So since both bases are 125, that means that I can use my power rule of adding the exponents. Since they're multiplying, I can add them together. So I take 3/12 plus 1/12, and that's going to be 125 to the 3/12 plus 1/12. That's going to be 125 to the 4/12, and 125 to the 4/12 is going to simplify down to the 1/3. Now that is like the cube root of 125, but you can also put that into your calculator, 125 to the 1/3, and you will get 5. So that's back like we did in example 2. You can put that exponent into your calculator of 1/3, and you will get 5. On to part B. Since we're dividing, this now means that we will subtract. So we've got a 9 as our base, 7/2 minus 3/2. So denominator of 2 means that that's just going to be in my answer. So I'm just basically doing the 7 minus 3, which is 9, to the 4/2, which is 9 squared. And then 9 squared is equal to 81. So there would be our result there. And lastly, I've got this 15. So I've got a product to a power. All the values inside here are going to get multiplied by this 15. So it's that second to last product to a power property that we talked about on the previous page. So if you want to rewind to look at that, or you can check your notes. Now we've got x to the negative 3/5 times 15. That's going to be x to the negative 45. I'm just taking 3 times 15, that numerator of 3 times 15 over 5. And then I've got my y to the 5 times 15 over 3, and 5 times 15 is 75 over 3. Continuing, that's going to mean that my x is raised to the 45 over 5, which is negative 9, y to the 25th. Now, x and y are different, so I cannot do any other combining together with these exponents. But since x is raised to the negative 9, this is that very first power property on the previous page. Anything that's negative is going to go down to the denominator. So that whole power, x to the 9th, is going to go down into my denominator. And it becomes a positive exponent. So there would be our final result. Part B, we got 81. Number 1, we got 5. Take a look at how algebra relates into these rational exponents. And we're going to use one of our power rules. We're going to use the power rule of power to a power. So if you have a power x to the m and you raise it to the nth, you multiply those two powers together. And then we're dealing with a variable being raised to an exponent of 1/5. And whenever we're trying to get algebra problems solved out, we're trying to get that variable alone. So here, when we're dealing with exponents, we're trying to get that exponent to be 1. So we're thinking about how could I multiply 1/5 to make it 1? And that would be called your reciprocal. So if I raise this to the 5th power, that would cause me to multiply those two exponents. And I got to keep both sides balanced. So that's going to give me my x to the 1st power, 1/5 times 5, and then 5 to the 5th is going to be what my solution is. So I get x is equal to, and you can do 5 to the 5th in your calculator or use your power sheet, but you're going to get 3,125. On to problem 2. If you take x to the 3/4 on both sides, raise 81 to the 3/4. Well, x is now being multiplied by its reciprocal, so 4/3 times 3/4 makes it x. And 81 to the 3/4 is going to equal to 27. So there's how we can start to see algebra fitting into this. We can raise to the reciprocal powers to get that variable alone. Learning target today, Jorge can rent a cubicle storage container 12 feet on each edge. He estimates that he needs double this amount of storage space. What are the dimensions of the cubicle storage container that has enough space for all of his stuff? So he has a storage unit right now, and it's a cubicle. So that means it's a cube shape. So we can just draw a little picture of that. And right now, his cube is 12 on a side. So if it's got 12 on each side, 12 feet, its volume is going to be 12 times 12 times 12, which is 1,728, which is basically 12 to the third power. Well, that's not enough storage for him, so he needs to double that. So if we take that and times it by 2, the storage that he needs is 3,456. 3456. So his new container needs to have double the volume. So here's his new container, the red over here, and he wants it to be double the volume. Now you might just think, well, I just double all the dimensions, I'll make them all 24. Well, that is not really the case, but I do know that something has to be the length, width, and height, and all three of those need to be exactly the same. So here's kind of what we're looking at. We need x cubed to equal 3,456. And just like above when we were solving, we can raise each side to the power of 1/3. The reciprocal of 3, raise this to the 1/3. And we'll get, for our dimensions, x needs to equal about, I'm going to put to the nearest tenth, 15.1 feet. So if you extend that cubicle shape to 15.1 feet, that will double the storage space. So we could start by finding the volume of the original, double it to make 3,456, and then figure out what do the 3 x's need to be to equal 3,456. So that finishes up lesson 59, and our learning target today was to extend the laws of exponents to include those fractional exponents. So you're now ready for the class check. Thanks for checking in. Good to see you, and we'll talk to you later. Goodbye.